Well, we will see how to get the derivative of this expression, this function, which is the square root of x to the ln x. First, obviously, we have to transform the square root into 1/2, which is the exponent of x ln x, and then using the chain rule we will get this expression. First we get the derivative of this whole expression, which is this 1/2 x ln x to the minus 1/2, and then we get the derivative of the expression which is inside the parenthesis, which is the same, x ln x. Then with this we use the rule of exponent functions, and first using this expression, which gave us this expression in the numerator of the division, and then with this other expression that we have here, we just transform again this into a square root using the exponent 1/2, and then we multiply it by the 1/2 that is outside, and that leaves us with this expression 2 square root of x ln x. Then we just add the two ln's that had here inside, that give us ln 2x, and the same multiplying by the same expression that we had here, and then we just get the derivative of this expression using chain rule, and that leaves us with this, multiplying again by the same x ln x, and finally we just simplify by canceling the 2's that we have up and down, and then by transforming the ln x into 1/x. Then just multiply this 1/x with this, and we pass this to the other side, and that will be it.
So now we're gonna do the next problem, which is tan of x to the ex. So we can see the problem right there. So first what we need to do is the logarithmic properties. That will be this. I'm gonna put the ln, the derivative here, and tan of x. Okay, so we will use this one throughout the process. Now we need to do the chain rule for this. So now it will be ex of ln tan of x times ex ln tan of x. Now as you can see, this is multiplying, so we need to do product, and it would be like this. This remains the same. Now here we put the e to the x times ln tan of x plus ln tan of x and the derivative. Okay, so as we have this, we need to do again the chain rule. So this would be ln always stays the same like this, and here is what we change. Now instead of putting this, we're gonna change it to 1 divided by tan of x, multiplying tan of x plus ln tan of x, and this e right here. Now this tan needs to change in sine and cosine, so what we're gonna do is change that. We're gonna have this one, tan of x times the ex, another one, and now we're gonna change that. Sine divided by cos, then tan of x plus ln tan of x e of x. Yeah, okay. Now we already have this, so we know that this will convert to cot. Then we're gonna put like this: ex ln tan of x to ex, then cot of x times tan of x plus ln tan of x times the e with the power. Now, the derivative. We need to have the derivative of tan, so we're gonna change this tan, we're gonna change it into sec squared. Okay, so we're gonna have it like this. Ln stays the same as always. Then the ex cot x, and this changes sec squared times x plus ln times tan x e to the x. And finally we need to simplify all of this, so it will be ex plus e to the x again, then ln tan of x times sec square cot x, I was missing here, and finally I'm gonna put like this: ln tan of x ln tan of x. So this will be the final answer. All of this, as you can see, will be e to the x plus e all also to the x ln tan of x sec squared cot plus e to the x plus e squared, all that, times tan of x, and then all of this multiplying ln tan of x. Okay, so that will be. Thank you.
Ok, empezando este problema nos podemos dar cuenta que va a ser una regla del cociente. Entonces empezamos con el denominador al cuadrado por el numerador al derivado por lo de abajo normal, pero acá arriba es un producto, entonces se va a desarrollar a todo esto, que sería, pues aplicamos chain rule, y como es producto es derivada del primero por la misma del segundo, más la misma del segundo por la derivada del primero. Y pues bueno, multiplicamos por el denominador para que sea la primera parte del cociente, menos lo mismo de arriba por la derivada de abajo, que nos da esto. Continuamos, simplemente pasamos los negativos, los exponentes negativos al denominador. Vamos simplificando, vamos juntando los términos que podamos y nos resulta en esto. Después me di cuenta que hay un x5 en las dos partes, entonces x menos 5, perdón. Saqué el factor común, que sería la tercia, porque este es cuarta, este es tercia, el más chiquito es tercia. Saqué el tercio, se eliminé y 3 de este. Después se cancela esta x tercia con este x octava y nos queda x quinta. Después aquí ya no hay nada más que se pueda hacer, porque estos denominadores no son iguales, ni numeradores, doble racionalizar es prácticamente imposible. Estos terms no son parecidos y pues, por lo mismo estos no se pueden sumar ni restar. Entonces, esta es la manera más simple.